Hi there, welcome back to the next video. So, as I said in the introduction, this platform we're going to build is going to need to support a dynamic data model. And by this I mean that our model should be defined by a user within the system itself, and therefore we need to build a mechanism or service that will allow us to do that. From a traditional tables and fields perspective, we'll have a schema as a holder for a set of attributes or elements, which will have one or more schema elements that will define what type of data we're storing. We'll then have the data model object itself that stores the actual data, with one or more model elements that store the actual field level data. Our model data will hold intrinsic links to the underlying schema, as with one without the other it's pretty useless. Thus, in a traditional development sense, our data structure might look like something like this, whereby we will have our schema template that will have a name and description, and that'll have a collection of schema elements that will be our table fields. And then linked to that we'll actually have our model, which will just be a holder for each record, and then that record will have a number of, again, fields within that table that will be linked back to the schema and then store the actual value. Okay, let's run through this concept a little bit more to compare what to do if we were using this under a normal development using SQL Server. So if we're going to do this the long way around, so let's say we wanted to be able to store customers. Okay, so we'd create a customers table that might contain an ID, a customer name, and the city that they're sitting in, which is this table over here. But as I said, we don't want to do that because this needs to be a dynamic system. So every time a user wants a new type of data to be stored, we don't want to have to go to the database and script all this out. So what we're going to do is we're going to use the schema table that might look like this, and in there we'll create the schema table itself that we'll just give it a name. So for example, the schema will be called customer, and then to that customer table we will have a number of schema elements, and each of those schema elements, will think of it kind of like a column or an individual field within a table. So for example, we might store a customer name, which will be stored as a string, and then we might store a city, which again we might store as a string. If we actually built our table out and looked at it in SQL Server, it might look a bit something like this. So we'd have the schema here and the schema definition here, and then these here are the actual results. So the actual model itself would just simply be basically a holder with an ID, and then it would have a number of records which each relate back to that ID that contain the values. So what we have here, we've got the schema with an ID of 1, which we'll call schema. That schema's got a number of columns, one called customer name, one called city. And then we actually have our data here. So the first thing is we'll create a data record, which it's referencing the schema ID 1, which is this, so we know it's a customer record, and then it will contain a number of data elements. So we've got the first one here, which is relating back to this model here, but the schema element is that one, which is, so the customer name would be complete coda, and then the schema element 2, which is the city, is going to store the value London. Now the SQL itself might look something like this. We'd do a join on the tables to bring back, for example, what the schema name is, i.e. think of it like the table name, followed by the number of elements and values that we want in there. So the result might come back like this, which looks a little bit more in the traditional sense that you'd expect to see a customer table. Okay, so that's the overview of what it's going to look like. Let's go ahead and start building this out from a brand new project. Okay, so I'm going to store the code for all this in a couple of repositories. I'm going to store it in Azure DevOps and GitHub. Now, I'm putting it into GitHub just because people are just more used to using GitHub, but I want to put it in the Azure DevOps as well because I want to use all the pipeline tools that Azure DevOps gives us. So if you are going to be following along and you're going to be doing this exactly as I am, then get yourself an Azure DevOps account. It's absolutely free. Just go to dev.azure.com, sign in with a Microsoft account or create one. As I say, it's absolutely free. Once you're in, let's create a new project. I'm going to call this Agility YouTube. I'm calling it Agility because it's an agile type platform. I'm going to set it to public so that you can access it yourself if you want. And I'm going to set the work item process to Scrum, just because that's what I'm a little bit more used to as opposed to more standard Agile. Let's go ahead and click Create. Incidentally, the links for all these I will put in the comments underneath. Once our project's created, the next thing I want to do is set up our repos. By default, when you create a project in Azure DevOps, it creates a repository of the same name. But I want to use different components in different repositories. So what I'm going to do first of all is in the top here where we've got our default repo, I'm going to go and say new repository. And what I'm going to do is I'm going to be creating a different repository for each component of our agility solution. So this one is going to be the core data that we're building. So I'm going to call the repository core data. We'll add a README and we'll add a Visual Studio gitignore file. Once that's done, I'm going to switch over to Visual Studio, go to Team Explorer, and I'm going to connect to a new project, and I want my Agility YouTube and the core data repository, so go ahead and click Clone. Now I've got that, the first thing I want to do is create an empty blank solution. So we'll go to Solutions and New. We want other project types, Visual Studio Solutions and blank solution. Again, for the solution name, I'm just going to call it core data. And then once we have our solution, what I want to do is to start creating a set of individual projects. The main project we're going to want, of course, is an API. So let's go add new project. This is going to be a web project. It's going to be ASP.NET Web Application .NET Framework. We're not using ASP.NET Core. We're using the standard framework here. And when we do naming, I often name all my applications using naming methods. So for example, I'll start with my solution name, and then I'll give it a name that's based around the function that I'm trying to create. So this one is going to be core data, and then finally I say what the component is. So in this case it's web API. I'm going to use an Azure API app, and I'm going to add some unit tests, and everything else I'll leave as it is. Once that's created, I'm going to create some more projects. So these are going to be, this is where I'm going to separate out my modules. So we could actually do everything within Web API, but at some point in the future we might want to reuse some components. So what I'm going to do instead, I'm going to create some separate projects within our solution, and these are all going to be Windows Desktop and class libraries. Again, make sure we're selecting .NET Framework here. Again, we're going to follow the naming convention, so Agility, but this one I'm not going to say this is necessarily specific to core data. This is the core data. This is going to be, I'm going to call it .core, because this might contain components that will be used across my projects. Next, for our core data itself, I'm going to have some models and some view models. So I'm going to have Agility. Now, because these models will only pertain to the core data, I'm going to say core data, and then we'll say models. And then again, we'll do the same. Whoops. Add project. And this time we shall call it agility.core core data.viewModels. Okay, with our projects in place, let's go ahead and start actually creating some of our models. So before I do anything, I'm going to create a class in our core project called Entity Base. So Entity Base is a class that all other models will inherit from, and in here we can set some default functions that we always want our database driven models to implement. So the first thing I'm going to do is in agility.core is add a folder called models. Eventually we'll be adding other folders to a core, such as infrastructure or interfaces, but for now I just want a base model. I'm going to add a new class and I'm going to call this entity base. Set it to public, and we're going to have a string called ID, and this will mean that all models that implement entity base will automatically get a string of ID, and this will give us consistency across the project, but it also makes it easier when we're starting to try and build generic classes. For example, when we come and build a generic data persistence class, which you'll see later on. Next I'm just going to create a constructor that simply creates a GUID, so that every time we create an instance of this class, it's just going to create a new GUID. Now the reason why I use string rather than, for example, int or perhaps even a GUID itself is because different databases use different ways for creating IDs. So for example, in SQL you could use IDs as integers and have it automatically increment that integer, or you could have it as a GUID and again have the database automatically create that for you. However, other database implementations might not support that. What is common across all implementations is the ability to have an ID field as a string, and so by doing that it makes our models independent to any underlying database mechanism we might choose, and at some point we might even choose the underlying data mechanism that we use. So once that entity base has been created, we can close that down. Let's just get rid of this class 1 here because we don't need that. And next let's go into our data models and start creating our core models.